Welcome students. In this particular lecture we will start off by discussing a very important difference, that is the difference between 0 to 2 pi of sin x dx and the area enclosed by f of x is equal to sin x between x is equal to 0 and x is equal to 2 pi. So we need to know the difference between this quantity which we see here and between this which we see here. Now let me just draw the graph of y is equal to sin x. I'm going to draw the graph for the region 0 to 2 pi. So the division would be 0 to pi and then 2 pi. The graph would start here, hit here, and then move up like this, right? So if we were to integrate this 0 to 2 pi of sin x dx, it would be integral 0 to pi of sin x dx positive pi to 2 pi sin x dx. Integral of sin x is cos x, limits are 0 to pi. Positive integral of sin x is negative cos x, limits of 0 pi to 2 pi. And if I were to substitute the limit, it's going to be cos of pi minus cos of 0. I can take the negative sign out and substitute the limit, cos of 2 pi negative cos of pi. So this is what I have got. Now this is going to be cos of pi is negative 1, cos of 0 is 1, that's going to be negative 1 here. And this is going to give us 1, this is going to give us negative 1. If I were to add up these two things, this is negative 1 would give me negative 2, negative 1 of negative negative, that's going to be 1, positive 1, that's going to be giving me 2. Now this is equal to negative negative positive 2, I have a negative 2, so I get 0 here. Now this would mean, so I can just say therefore integral 0 to 2 pi of sin x dx is equal to 0. Now why it is 0? Because the region from 0 to pi would give us positive 2. That's exactly what we've got here. And after we have obtained the region from 0 to pi, which is positive 2, the region from pi to 2 pi, pi to 2 pi would give us negative 2. This is going to be giving us negative 2, right? So if we were to sum up these two things, positive 2 and negative 2, the outcome is giving us 0. Now on the contrary, if they are asking us to find the area, they can use the term either under or enclosed, right, by the curve f of x is equal to sin x. If this were to be the question, then integral 0 to 2 pi, of course the region for x being between 0 to 2 pi, right? So this integral 0 to 2 pi sin x dx is going to be equal to the first region which we got. Okay, let me divide this 0 to pi sin x dx positive pi to 2 pi sin x dx. Now this and subsequently this region is going to give me, let me just place the sign positive, and this would be negative 2 here. So if I were to rewrite this, this is going to be positive 2 and this is going to be positive of negative 2. But since we are asked to obtain the area enclosed by the curve f of x is equal to sin x, the biggest thing in this case is area is never negative. So these two things will be featuring inside the modulus, right? And that would mean the outcome is going to be 2 added with 2, which is equal to 4 units. So that is the important point we will have to take into consideration. So the final take home point is, if they ask you to obtain the integral of sin x between the region 0 to 2 pi, then the solution is going to be equal to 0. On the other hand, if they ask you to find the area enclosed by the function f of x is equal to sin x, then the solution would be 4 units. So area is never negative, and that is the reason that we need to enclose the outcome inside the modulus sign. So have these two things in mind, and it is important that we know the differences that are existing between area and finding the limit of the function given the limit value, lower bound and upper bound. Students are expected to find the value of integral 0 to pi modulus of sin 2x dx. Now foremost, what I wish to do is, let me consider the given question, 0 to pi modulus of sin 2x dx. Now I'm going to substitute, let 2x be equal to t. So from here 2 times dx is dt, and dx is dt over 2. Now let me transfer the limits in terms for t. So when x is equal to 0, we got t to be equal to 0. When x is equal to pi, we got t to be equal to 2 pi. So therefore, the given integral 0 to pi modulus of sin 2x times dx now becomes integral 0, in fact when x is equal to 0, t is equal to 0, that's fine. When x is equal to pi, t is equal to 2 pi, that's good. So this is going to be modulus of sin 2x is taken as t within the modulus, and dx is dt over 2. I'm going to rewrite this as 1 over 2 integral 0 to 2 pi modulus of sin t times dt. Now this is similar to integral 0 to 2 pi of sin x dx, right? Now clearly, if we were to look into the graph of sin x, this is exactly going to be the graph. So this is going to be 2 units, this is going to be negative 2 units. But apparently for integral 0 to 2 pi modulus of sin t dt, the graph is going to be like this. Okay, this is going to be graph 0 to pi, and the graph is not going to go down because we got the modulus sign. So the graph is going to rise, and it's going to be hitting at 2 pi again. And this is going to be 2 units. This is also going to be equal to 2 units. So this would mean integral, of course there is a 1 over 2 there, which we have obtained here, 0 to 2 pi modulus of sin t dt is equal to 1 over 2 times, for if I were to split this, okay, 0 to pi modulus of sin t dt positive pi to 2 pi modulus of sin t dt. I am not using the technique of integration to obtain the value. I am using graphical method. Okay, so this is equal to 1 over 2 times integral 0 to 2 pi is 2 units, and integral pi to 2 pi, this is also equal to 2 units, which is 4 over 2, which is equal to 2 units. So this is the solution. Now I can also obtain this by using the technique of integration. That's exactly what I'm going to do now. Now I'm going to show how exactly we can obtain the solution for this question, integral 0 to pi modulus of sin 2x dx, using technique of integration. So I'm going to rewrite this in this fashion. So I'm going to split 0 to pi to be as 0 to pi over 2 and then pi over 2 to pi. So this is rewritten as integral 0 to pi over 2 modulus of sine 2x dx positive pi over 2 to pi modulus of sine 2x times dx. Now we would have to obtain the sign for the modulus. Now let us see the sin x function. Say f of x is equal to sin x. We have 0 here, it reaches pi over 2 and then pi and then so on and so forth. So I'm just considering the first half of the quadrant. So we know this ratio, all silver tea cups. Now for f of x being equal to sin x, sine will be positive here, sine will be positive here, but we are given f of x is equal to sine 2x. Okay, so let me write that with clarity, sine 2x. So in that case, between 0 to pi over 2, sine 2x will open with a positive sign. So we can write that down, 0 to pi over 2. But when it comes to pi over 2 to pi, sine 2x will open with a negative sign. So this is going to be negative of sine 2x. So that is a very important differentiation that we will have to, in other words, a very important difference that we will have to observe between f of x being equal to sin x and f of x being equal to sine 2x. So having obtained the sign, let us integrate. So integral of sine 2x is going to be negative cos 2x, coefficient of x is 2, so we divide by that and we apply the limits 0 to pi over 2, positive. I can take the negative sign out and integrate sine 2x, that's going to be cos 2x. Of course there is going to be a negative sign, let's place that, divided by 2. The limits are pi over 2 to pi. Now if I were to substitute the limits, so I substitute the upper limit, this is going to be cos of 2 times of pi over 2, that's cos pi, so that is going to give me, in fact I can take 1 over 2 out which has a negative sign, so that would ease up my application part. So for the first upper limit I would get negative 1 followed by a negative of cos 0, cos 0 is 1, so this is what I'm going to get, right? So this is for the upper limit and the lower limit for the first term, followed by negative positive, I can take that out, I can take a 1 over 2 out and I can substitute the upper limit cos 2 pi will give me positive 1, negative of pi over 2. So if I were to substitute pi over 2, I would get negative 1. So this is what I would get. So this is equal to negative 1 over 2. Negative 1 is negative 2. Positive 1 over 2 times negative of negative 1 is going to be positive. So this is going to be positive 2 over 2, positive 2 over 2, which is equal to 1 positive 1, which is equal to 2 units. Right, so this is exactly what we have got, 2 units. You see that? This is by a shortcut, just by comparing the graphs, and this is by integration. So having obtained this solution, we will move on to the next question, students. Students, we are given this question, evaluate integral 0 to 1 ln x dx, and simultaneously we are also given this question, find the area under the curve y is equal to ln x with x ranging or x going from 0 to 1. Now this is asking us to find the area while this is asking us to evaluate. So there are two difference, or I should say there is a wide range of difference between the terms that are being used in these questions. Though the function is one and the same, the result would be totally different. So let us first consider integral 0 to 1 ln x dx and let us evaluate this. So I'm going to use Liet concept. So if you were to use Liet, you would have to take u is equal to ln x and dv is equal to dx. This is du is equal to 1 over x times dx. If I were to integrate this, I get v is equal to x. So the formula is uv negative integral v du, which is ln x times my v is x. I can place here, the limits are 0 to 1, you need to place that, followed by a negative sign, and v is x and du is dx over x. So clearly the x can be cancelled, so this would give us x times ln x, limits are 0 to 1, negative integral dx, of course the limits are 0 to 1. So this is equal to, I substitute, okay, let me just get the integration out of the way. So this is going to be x times ln x, limits are 0 to 1. Integral of dx would give me x, the limits are 0 to 1. Let me substitute the upper limit followed by the lower limit. In fact, we can do it like this for the first case, and this is going to be 1 negative of 0. Now ln 1 is 0, 0 times ln 0 is 0, and this is going to give us negative 1. So I can rewrite here, therefore integral 0 to 1 ln x dx is equal to negative 1. But when it comes to area under the curve, what they're asking us is, they're asking us to obtain this region. So if I were to draw the graph would look something like this, right? So they want this region, the area enclosed by this particular curve. So this is my graph, y is equal to ln x. Now to get the area, what we need to do is we need to take the modulus of negative 1, and that is going to be positive 1. So this region or this area is going to be 1 unit or 1 square unit. That's the best way to say. So have this in mind. There's a lot of difference between evaluating and obtaining the area enclosed or area under the curve y is equal to ln x. So having mentioned this, I think we need to have a demarcation for this so that you would be in a better position to understand it. So we'll move on to the next question, students. Students, we are expected to evaluate integral 0 to 3 greatest integer function of x times dx. Now this could be rewritten in this fashion, taking the integer quantity 0 to 1, positive 1 to 2, and then 2 to 3. So having split this, so what we have to find out is what happens when x varies from 0 to 1. Clearly the value would be 0. The greatest integer quantity for x when it varies from 0 to 1 is going to be 0. So we need to place the differential operator. In this case, when x varies from 1 to 2, the value of the greatest integer function would be 1 here, and in this case it's going to be 2 here. So this is what we need to integrate. Of course this is going to be 0, and integrating this would give me x, the limits are 1 to 2, and integrating this would give me x, the limits are 2 to 3. I substitute the upper limit minus the lower limit, followed by 2 times the upper limit minus the lower limit. This is going to give me 1, this is going to be giving me 2 of 1, which is equal to 1 positive 2, which is equal to 3 units. So this is the solution. You don't have to write it as units, you can simply write it as 3 for this particular question. So let's move on to the next question. Now if in case they're asking us to find the area enclosed by the greatest integer function, or area under the curve of f of x being equal to the greatest integer function of x, then we can also apply graphical technique. So let me just draw the x-axis and the y-axis, and let me mention the points. 0, this is going to be 1, this is going to be 2, this is going to be 3. Now definitely 0 to 1, this is going to be 0, and 1 to 2, the region is going to be 1. So this is 1, this is 2, and we got the point 3 over there. So this is going to be a straight line there, and there is going to be a discontinuity here. There's going to be a break, and it will start from 2 and it will move up to 3. So this is how the step looks, or the graph looks for the greatest integer function. So if we were to find the area under the curve, then this is how it will look. Okay, So this is what is required. Now if you were to observe this, clearly this area is going to be 1 unit and this area is going to be 2 units. So the total area under the curve is going to be 1 positive 2, which is equal to 3 square units. So that would be the solution, so which is obtained merely by drawing the graph for the greatest integer function. So this is another way, or maybe probably I can represent this as 1 and 2. So let's move on to the next question, students. Students, let's do this question. We've been given this question to evaluate limits, or I should say the lower bound to upper bound is extending from -1 to +1, and the function is x cubed times tan of x squared times dx. So we have a property. What is the property? I'm going to state that we know that integral -a to a f of x dx is equal to 2 times integral 0 to a f of x dx when f of x is a even function, or is an even function. On the other end, this is equal to 0 if f of x is an odd function, right? So the question comes here, is this even or odd? So we need to make the decision here. So let me consider f of x to be equal to x to the power of 3 tan of x squared. Now to ascertain if it is an even function, we need this property. F of x is even if f of negative x is equal to f of x, and f of x is odd if f of negative x is equal to negative f of x. Right, so having mentioned this property, let me just substitute x being equal to negative x in say 2. So let me just take this as 2. So this would mean f of negative x is equal to negative x raised to the power of 3 tan of negative x raised to the power of 2. This is going to give me tan x squared, so that is comforting. This is going to give me negative x cubed. But what is f of x? X cubed times tan of x squared, which is equal to negative f of x. So this means f of negative x is equal to negative f of x, which in turn means f of x is an odd function. Because it is odd, this would mean integral -1 to 1 x cubed tan of x squared times dx is equal to 0, and it is a good place for us to draw the red line. Of course, I have included a lot of steps. You don't have to include this many steps. If you are sure the function is even, or on the contrary the function is odd, subsequently you can make your decision and write the solution. So let's move on to the next question, students. Students, we got another beautiful question to evaluate. It is from -1/2 to +1/2. Secant x ln of 1 negative x over 1 positive x times dx. So as I mentioned to you, we will be using this property. We know that integral -a to a f of x dx is equal to 2 times integral 0 to a f of x dx if f of x is even, and on the other end it is equal to 0 if f of x is odd. So the major requirement here is to find out if this is odd or even. So let me just take this as f of x is equal to secant x ln of 1 negative x over 1 positive x. Now let me substitute x be equal to negative x. So this is f of negative x is equal to secant of negative x times ln of 1 negative of negative x over 1 negative x. This is equal to secant of negative x is going to give us secant x. This is ln of 1 positive x divided by 1 negative x. Now I can rewrite this as secant x. Now can I write this as 1 over 1 negative x over 1 positive x? Is it okay for me to write it like this? Because if I were to flip this, this is going to be ln of 1 positive x over 1 negative x, right? Now I'm going to rewrite this as secant x ln of, this quantity, can I take this to the numerator? So if I were to take this quantity to the numerator, this is going to be 1 negative x divided by 1 positive x raised to the power of negative 1, right? Because I have 1 over 2 here. If I want to take this 2 to the numerator, this is going to be 2 raised to the power of negative 1. I am using the same concept here. So 1 over this quantity is written as ln of the quantity raised to the power of negative 1. So I am just moving it up. So if I were to move it up to the numerator, the exponent would become negative 1. But we know that ln of a raised to the power of b is equal to b times ln a, right? So this would mean this is equal to secant x negative 1 times ln of 1 negative x divided by 1 positive x. So this is written as, taking the negative sign out, secant x times ln of 1 negative x divided by 1 positive x. But what is this? This is nothing but function f of x. So that's going to be negative of f of x. So this means f of x is odd. So since f of x is odd, let me conclude it here. This would mean integral negative 1 over 2 to 1 over 2 secant x of ln of 1 negative x over 1 positive x times dx is equal to 0. And this is a good place for us to draw the red line. Of course, I've included a lot of steps. You don't have to include this many steps. If you are sure that the function is odd, you can directly boil it down to 0. So we will move on to the next question, students. I hope you understood the steps that have been displayed here. And the next question is, students, we are expected to evaluate integral negative 1 over 2 to 1 over 2 of greatest integer function of x positive ln of 1 positive x over 1 negative x times dx. Now I'm going to rewrite this as negative 1 over 2 to 1 over 2 greatest integer function of x times dx positive negative 1 over 2 to 1 over 2 ln of 1 positive x divided by 1 negative x times dx. Now this is clearly an odd function, so this is going to be 0. Now previously we have shown this, that this is an odd function, and I suggest that you can go and have a review at it. Now we are expected now to integrate greatest integer function of x between 1 over 2 to, with a negative sign, to positive 1 over 2. Now I'm going to rewrite this as negative 1 over 2 to 0 greatest integer function of x dx positive 0 to 1 over 2 of greatest integer function of x. Now since we are dealing with greatest integer function of x, and x is actually from negative 1 over 2 to 0, then the value that the greatest integer function would take in this case would be negative 1 over 2. In this case it's going to be 0, and this is equal to negative 1 over 2, which is the solution for this particular question. Students, we are given this question. It's a beautiful question. To evaluate integral negative pi over 2 to positive pi over 2 x squared positive ln of pi negative x over pi positive x times cos x dx. Now I can rewrite this as integral negative pi over 2 to positive pi over 2 x squared times cos x dx positive negative pi over 2 to positive pi over 2 ln of pi negative x divided by pi positive x times cos x dx. Now clearly this is going to be an odd function, right? So that would mean integrating that would give us 0, but we are left with this. So let me write that down. So this is equal to integral negative pi over 2 to positive pi over 2 x squared times cos x dx. Now we can perform integration by parts, or we can use this DI method which I have just mentioned in the lecture on indefinite integrals under integration by parts. Right, I have mentioned that. Now I'm going to demonstrate that method and solve this, and let's see how it is done. Now before we could proceed, we want to know if x squared times cos x is an even function or an odd function. So let me just take the function f of x is equal to x squared times cos x, and let me just take x to be equal to negative x. So we got f of negative x is equal to negative x raised to the power of 2 times cos of negative x. This is going to give me positive x squared. This is going to give me positive cos x. And clearly this is nothing but positive f of x. So this would mean the given f of x is an even function. Now because it is even, I can rewrite this as 2 times integral 0 to pi over 2 times x squared times cos x. So now we will apply the DI method. So write D stands for differentiation, I stands for integration. Let me take the first quantity x squared and the second quantity over here. I differentiate x squared, I get 2x. I integrate cos x, I get sin x. I differentiate 2x, I get 2. I integrate sin x, I get negative cos x. This is differentiation of 2 would give me 0, and the integration of negative cos x is going to give me negative sin x. Now we need to start with a positive sign, a negative sign, a positive sign, and a negative sign. And then what we need to do is we need to club this with this, this with this, this with this. So let's do that. So this is equal to positive sine of x squared times sin x, negative negative positive of 2x times cos x, 2 times negative sin x, right? Because of the presence of positive sign, positive times negative will give me negative. The limits are actually from 0 to pi over 2. So we need to place that limits. So this is equal to, applying the limits, I get pi over 2, the upper limit, right? So we need to do that. And since there is a presence of a 2 here, this is going to be pi over 2 raised to the power of 2 times sine pi over 2 negative lower limit 0 followed by positive of 2 times pi over 2 times cos of pi over 2, that's going to be 0, negative 0, so that's gone. This is followed by negative 2 times sine pi over 2. So this is equal to pi squared divided by 4, and this is off. This is going to give me negative 2 here, right? That's fine. So I need to take this value and substitute it here. So therefore, let me write the answer here. So therefore, 2 times 0 to pi over 2 x squared times cos x dx is equal to 2 times of pi squared over 4 negative 2, which is equal to pi squared over 2 negative 4 units, right, the respective units. So this is a good place for us to draw the red line. So students, I hope you understood this question. It is a little bit lengthy, but with the useful method that I've just indicated here, the solution can be easily obtained. So having mentioned this, we will move on to the next question. Welcome students. Now we are going to see another important property of definite integrals. Now the property is, if we were to be given integral a to b f of x dx, then it can be rewritten as integral a to b f of a positive b negative x times dx. Now I will prove this result. So foremost, what we will do is consider integral a to b f of x dx. So from here what I would do is I would just let x to be equal to a positive b negative t. Differentiating, I get dx is equal to negative dt. Now with regard to the limits, when x is equal to a, you got a is equal to a positive b negative t. The a's would get cancelled, giving us negative b is equal to negative t. Therefore t is equal to b when x is equal to a. So when x is equal to a, my value for t is b, and similarly when x is equal to b, this is going to be a positive b negative t, and clearly b would get cancelled, giving us negative a is equal to negative t. Therefore t is equal to positive a. So in place of b I would have a, and in place of x I would have a positive b negative t. In place of dx it's going to be dt with the negative sign. I will place it over here. Now from the another important property of integrals, I can revert the integral limits, thereby the sign would get reverted also. So this would mean I would now have positive a to b f of a positive b negative t times dt. Now from the property of integral, if I were to replace t with x, then the integral would still remain the same. So this would mean integral a to b f of a positive b negative t dt can be rewritten as integral a to b f of a positive b negative x times dx. So this would mean we started with this integral a to b f of x dx, and then we ended with integral a to b f of a positive b negative x dx. So hence we can safely conclude that integral a to b f of x dx is equal to integral a to b f of a positive b negative x times dx. So this is a very important property that will come in very much handy in solving questions of greater complexity. So having mentioned that, let's head on to do questions. Let's do this question, students. Evaluate integral 50 to 100 ln x over ln x positive ln of 150 negative x times dx. I'm going to show you two ways to solve this question. The first way would be the longer way. So we know that integral a to b f of x times dx is equal to integral a to b f of a positive b negative x times dx. So this is the property we just saw a minute ago. So I will be using this property. So foremost, let me just let I be equal to integral 50 to 100 ln x over ln x positive ln of 150 negative x times dx. So if I were to use this property, I can rewrite this in the following fashion. So clearly you can see that wherever we have x has been replaced by a positive b negative x, right? You can clearly see that in place of x I've got a positive b negative x. That is exactly what I'm going to do. So this is equal to, now we have, from, if I were to mention this as 2, now we have from 2 or by 2, you can use whatever phrase that you wish to place here. Of course, I am sure that you are able to catch the meaning that I am trying to infer here. So I would be equal to integral 50 to 100 ln of a positive b. So 50 plus 100 negative x divided by ln of 50 positive 100 negative x positive ln of, in place of x I would be substituting 50 positive 100 negative x times dx. So So this is equal to integral 50 to 100 ln of 100, 50 added with 100 would give us 150 negative x, divided by, this is going to be ln of 150 negative x positive, 50 added with 100 would give us 150. We got a negative sign, so this would get cancelled with these two elements, and you got a negative x followed by a negative sign which is preceding the negative x. So that would mean you will have ln of x times dx. So this is equal to I. Now if I were to take this as 1 and take this as 3, because I've taken this as 2, so adding 1 and 3 we get. So what do we get? I added with I, this would be 2i, is equal to ln of this quantity 50 to 100 ln of x over ln of x positive ln of 150 negative x times dx positive this quantity integral 50 to 100 ln of 150 negative x divided by ln of 150 negative x positive ln x times dx. The denominator is one and the same, and thereby we can club them. So we got 2i is equal to integral 50 to 100 ln x positive ln of 150 negative x divided by ln x positive ln of 150 negative x times dx. So clearly you can see that the numerator and the denominator can be cancelled, giving us 2i is equal to integral 50 to 100 times dx. If I integrate this, I get x, the limits are 50 to 100. Substitute the upper limit minus the lower limit. So if I were to push the 2 down, you would get I is equal to 100 negative 50 divided by 2. So remember, this is the standard formula. So I can also represent this formula as I is equal to b negative a divided by 2. Of course, the solution can easily be obtained once we apply this, but I just want to show you how exactly we are able to get this. So this is going to be 50 over 2, which is equal to 25. So what is the solution? So therefore, when you integrate 50 to 100 ln x over ln x positive ln of 150 negative x times dx, you get 25. That's a value. Probably you can write it as 25 units. So this is the solution for this question. And we will move on to the next question. Students, we will draw our red line. Students, we are expected to evaluate integral 2 to 3 root of 5 negative x over root of x positive root of 5 negative x times dx. Now what I wish to do, I would like to take, let x be equal to 5 negative x. Then if I were to start off like this, let I be equal to integral 2 to 3 root of 5 negative x over root of x positive root of 5 negative x times dx, and letting x to be equal to 5 negative x, if I were to take this as 2 will now be rewritten as integral 2 to 3. If I were to substitute x is equal to 5 negative x, this would become root of x, this would become root of 5 negative x, this would become root of x times dx. Of course the limit will change, but that change would be countered with the negative dx, right? So it would revert back the form that I have just specified here. Now what I wish to do is I would like to add 2 and 3. If that were to take place, this would give us 2i is equal to limit 2 to 3 root of 5 negative x divided by root of x positive root of 5 negative x times dx positive 2 to 3 root of x divided by root of 5 negative x positive root of x times dx. The denominators are same, so this can be rewritten as 2 to 3 root of 5 negative x positive root of x divided by root of x positive root of 5 negative x times dx. So clearly I can cancel the numerator with the denominator, and that would give me integral 2 to 3 dx. On the left it's going to be 2 times I, so this is going to be x upon integration. The limits are 2 to 3. If we were to substitute the limits, it's going to be 3 minus 2. On the left it's 2i, so therefore from here I is equal to 1 over 2. So this is the solution that we have got. Now this same solution can easily be obtained from here, right? So therefore you can simply state that I is equal to upper limit minus lower limit divided by 2. So in this case it's going to be 3 minus 2 divided by 2, which is equal to 1 over 2. This same 1 over 2 is what we have got, right? This 1 over 2 is what we have got here. Now if they ask you in multiple choice question, then it's always better to use the faster way which I've just shown you here. This technique you can apply and the result would be obtained in a flash. So we'll move on to the next question, students. Students, we are going to look into forms of integral of this fashion: 1 over 1 positive e raised to the power of x, 1 over 1 positive a raised to the power of x, 1 over 1 positive 2 raised to the power of sine x, and then 1 over 1 positive 2 raised to the power of tan x. For all these forms, you can follow the method that I'm going to show you. So these are the forms that we would be focusing on, and what we will do is we will start off with this question: evaluate integral 0 to pi dx over 1 positive 2 raised to the power of tan x. Now what I wish to do is I would like to let I be equal to this, and then I'm going to set x to be equal to pi negative x. So from here dx is going to be negative dx, and then if I were to take x is equal to 0, then when x is equal to 0, the value of this x would be equal to pi, and when x is equal to pi, the value of this x will be equal to 0. So I can rewrite this as integral pi to 0. I got a negative dx. In place of this x, you can either take it as t, but I'm just taking it as x because I've already shown you how exactly, even though I would have taken it as t, still it will revert back to the original variable x because of the property of integrations that we have already studied. So having mentioned this, let's move on. So this is going to be pi to 0 with negative dx divided by 1 positive 2 times tan of, in place of x I've got pi negative x. So this is what I've got. I can revert back the integral, so this is going to be 0 to pi dx divided by 1 positive. Now tan of pi negative x, so what is that tan of pi negative x? So let us check that out. So let me write that down. Tan of pi negative x is nothing but tan of 180 negative x. Now tan of 180 negative x is nothing but sine 180 negative x divided by cos 180 negative x. So if you were to expand this, you can either expand it or you can directly use the equivalent trigonometric identity for this. So this is clearly going to be sine x, and this is clearly going to be negative cos x, which is nothing but negative tan x. So I can rewrite that over here, 2 raised to the power of negative tan x. Of course this is equal to I. Now I'm going to name this as 2, and I'm going to name the following outcome as 3. So let me just complete that. Now I can rewrite this as integral 0 to pi dx over 1 positive 1 over 2 raised to the power of tan x. If I were to take the LCM and rewrite it, this is going to be 2 raised to the power of tan x over 2 raised to the power of tan x positive 1 times dx. The limits are 0 to pi. So I will take this as 3. Now adding 2 with 3 we get. So on the left side, this would be giving us 2 times I. On the right hand side, we got integral 0 to pi dx over 1 positive 2 raised to the power of tan x added with this quantity, integral 0 to pi 2 raised to the power of tan x divided by 2 raised to the power of tan x positive 1 times dx. So adding this would give us 0 to pi 1 positive 2 raised to the power of tan x divided by 2 raised to the power of tan x. In fact, I could write it as 1 positive 2 raised to the power of tan x, but anyway, I started with 2, so let me write it in this fashion, times dx. Now clearly you can see the numerator and the denominator, they can get cancelled. So on the left I got 2 times I. So therefore 2 times I is equal to integral dx, limits 0 to pi. I substitute the limits and that would give me pi negative 0. So this would mean 2 times I is equal to pi. Therefore I is equal to pi over 2. So this is the solution that I've got. I is equal to pi over 2, and probably we could have obtained the solution from the output, or I should say from the question itself. So what is the take home point here? Now let me just tell you this. Now whenever they ask you or give you the question with either 1 positive e raised to the power of x or 1 positive a raised to the power of x, 1 positive 2 times or 2 raised to the power of sin x, or 1 positive 2 raised to the power of tan x, if they were to be featured in the denominator like this, integral dx over 1 positive 2 times tan x, 2 raised to the power of tan x, limits 0 to pi, you can directly get rid of this as a shortcut and then rewrite this as 1 over 2 integral 0 to pi dx, right? So have this important deduction in mind. Of course this is a shortcut, so since this is a shortcut, it actually arrives at the solution based on the pattern. So that is imperative to understand here. It has got nothing to do with the method that we have shown here. So this is the long method, this is the long way, and if they're asking you to solve this question, you will have to approach this question in this fashion. If in case you have been given MCQ, multiple choice question, then you can arrive at the solution in this particular technique which I have just shown you. So this is nothing but 1 over 2, I integrate dx, I get x, limits are 0 to pi, I substitute the limits, I still get pi over 2. So clearly you can see the answers are same. So students, let us do another question. We are expected to evaluate integral negative pi over 2 to positive pi over 2, 1 over 1 positive e raised to the power of sin x times dx. So this is what we have got. So as you would have remembered, I had clearly mentioned whenever you have a type of this fashion, 1 over 1 positive e raised to the power of x, or 1 over 1 positive a raised to the power of x, or 1 over 1 positive. In fact, I have mentioned in the previous question as 2 raised to the power of sin x. So it can be any a, any constant raised to the power of sin x, and simultaneously any constant raised to the power of tan x. If in all these cases you can clearly get rid of this quantity and multiply the integrand with 1 over 2. That is exactly what I'm going to do. So I'm going to rewrite this as 1 over 2. I'm going to get rid of this. So all I have is integral negative pi over 2 to positive pi over 2 dx, which is equal to 1 over 2 times, I can integrate dx, which would give me x. The limits are negative pi over 2 to positive pi over 2. So this is going to be giving me 1 over 2 times pi over 2 negative of negative pi over 2. So this is going to be LCM will be 2, and I will get a 2 pi there, and that's going to be 1 over 2. So 2 over 2 can be cancelled, and that would give me pi over 2. So this is the solution. Now you can actually verify this, right? You can actually verify this by the technique which I've just shown you in the previous question. Let's do another question, students. We are expected to evaluate integral negative pi to pi cos squared x over 1 positive e raised to the power of x times dx with the value of a greater than 0. As I mentioned to you, this can be gotten rid of, and once this vanishes, this integral has to be multiplied with 1 over 2. So we are having integral negative pi to pi cos squared x times dx. Now cos is an even function, so I can rewrite this as 2 times. I already have a 1 over 2 there, so 0 to pi cos squared x times dx. So 2 can be cancelled, giving me 0 to pi. Cos squared x is 1 positive cos 2x divided by 2 times dx. I can rewrite this as 1 over 2 times integral 1 multiplied with dx, that's going to be dx there, positive cos 2x times dx. So what we can do is we can place the integral sign like this. So 1 over 2 will be a common quantity. So the limits 0 to pi, upper limit upon integrating dx would give me x. So the limits are 0 to pi. This is going to give me sine 2x divided by 2. The limits are 0 to pi. So this is 1 over 2. Upper limit is pi, lower limit is 0. This is going to be, when I substitute, let me write that down here, 1 over 2 times sine of 2 pi minus sine of 2 times of 0. So this is what you are getting. So this will vanish, and the outcome is going to be pi over 2. We got one more question in this following pattern to evaluate. Integral negative pi over 2 to positive pi over 2 cos squared x divided by 1 positive 3 raised to the power of x dx. So this is the pattern I've shown you. So you can get rid of this by multiplying the integral with 1 over 2. So this is going to be negative pi over 2 to pi over 2 cos squared x dx. I can rewrite this as 2 times of 1 over 2 because cos is an even function. So 0 to pi over 2 cos squared x dx. This is going to be 1 positive cos 2x divided by 2, 0 to pi over 2 times dx. I can take 1 over 2 out. So this is going to be integral dx, positive integral cos 2x dx. Of course, the limits are 0 to pi over 2, 0 to pi over 2. This is equal to 1 over 2 times integral of dx would give me x, 0 to pi over 2, plus integral of cos 2x is going to be sin 2x divided by 2. The limits are 0 to pi over 2. This is going to be 1 over 2 times pi over 2 minus 1 positive 1 over 2 times sine 2 times of pi over 2 minus sine 2 times of 0. Right? So this will get cancelled, this will get cancelled. You get pi over 4 as the final answer to this question. Students, we are given this question. We expected to evaluate 2 over pi integral negative pi over 4 to pi over 4 dx over 1 positive e raised to the power of sin x times 2 negative cos 2x. I've already mentioned to you how to get rid of this 1 positive e raised to the power of sin x. So this would in turn result in us multiplying the entire integral with 1 over 2 followed by 2 over pi integral negative pi over 4 to pi over 4 of dx over, this is neutralized, and because of this being neutralized I'm getting 1 over 2 here. So all that remains is 2 negative cos 2x. Now I can clearly cancel the 2 here, so that is going to give me 1 over pi integral. Now negative pi over 4 to pi over 4 of 1 over 2 negative cos 2x. Clearly this is an even function, so I can write this as 2 times, right? So 2 times of 0 to pi over 4 dx over 2 negative cos 2x. Now we know a formula. What is that? Cos 2x is equal to cos squared x negative sin squared x. But cos squared x, I'm going to retain cos squared x as it is, but I will retain, or I should say I will rewrite sin squared x as 1 negative cos squared x. So this is going to be equal to cos squared x negative 1 positive cos squared x. I can add these two to give cos squared x with the 2 being multiplied there, followed by a negative 1. So what is this? This is my cos 2x. So hence I can rewrite this integral as 2 over pi integral 0 to pi over 4 dx over 2 negative of 2 times of cos squared x negative 1. Now what I wish to do is, okay, first let me simplify the denominator. So this is 2 over pi integral 0 to pi over 4 dx over 2 negative times negative 1 is positive 1 followed by negative 2 times cos squared x. So this is equal to 2 over pi integral 0 to pi over 4 dx over 2 added with 1 would give us 3 followed by negative 2 times cos squared x. Now what I wish to do here is I'm going to multiply the numerator and denominator by secant squared x. So this is going to be 2 over pi integral 0 to pi over 4 secant squared x in the numerator divided by 3 negative 2 times cos squared x times secant squared x in the denominator. So this is equal to, I will distribute secant squared x in the denominator. So this is 2 over pi integral 0 to pi over 4 secant squared x times dx divided by 3 times secant squared x followed by negative 2 times cos squared x times secant squared x. Now we know that secant squared x is 1 over cos squared x, right? So therefore cos squared x times secant squared x is equal to 1. So this is equal to 2 over pi integral 0 to pi over 4 secant squared x dx divided by 3 times secant squared x negative 2. Now we know a formula, secant squared x negative tan squared x is equal to 1. So secant squared x is rewritten as 1 positive tan squared x. This is always possible. So I'm going to use this result over here. So this is going to be 2 over pi integral 0 to pi over 4 secant squared x dx divided by 3 times of 1 positive tan squared x negative 2. So this can be further rewritten as 2 over pi integral 0 to pi over 4 secant squared x times dx divided by 3 times 1 positive 3 times tan squared x negative 2, which is equal to 2 over pi integral 0 to pi over 4 secant squared x dx divided by 3 added with negative 2 would give me 1 positive 3 times tan squared x. Now I wish to make the following substitution. So I'm going to say let tan x be equal to t. Differentiating, I get secant squared x dx is equal to dt. So this is equal to 2 over pi. I'm not going to touch the limits as now. So secant squared x dx is going to be dt divided by 1 positive 3 times tan x is t. So it's going to be t squared. Now the limits, let me just change the limits. So now when x is equal to 0, t will be equal to 0. When x is equal to pi over 4, t will be equal to 1. So this is going to be 0 to 1. I can rewrite the integral as 2 over pi integral. I wish to take 3 out. So if I were to take 3 out, this is going to be t squared positive 1 over 3. Now let me rewrite this as follows. So 2 over 3 times pi integral dt over the limits are 0 to 1. This is divided by t squared positive 1 over root of 3 raised to the power of 2. I can rewrite 1 over 3 as 1 over root 3 raised to the power of 2. Now we know that integral dx over x squared positive a squared is 1 over a tan inverse of x over a positive c, right? So if I were to use this formula, this is going to be equal to 2 over 3 times pi 1 over a times tan inverse of x over a. Of course the limits are 0 to 1, so this is going to be, I'm going to push this off to the numerator, 2 times root of 3 divided by 3 times pi tan inverse of root of 3 times t, limits are 0 to 1. I substitute the upper limit minus the lower limit, so this is going to be 2 times root of 3 divided by 3 pi. When I substitute the upper limit, I get tan inverse of root 3 followed by tan inverse of root 3 times 0. So this one goes off. This one would give us, let me write that down, 2 times root 3 over 3 pi. This is going to be pi over 3. So I can cancel the pi's here and I can rewrite this as 2 times root of 3 divided by 3 multiplied with 3 gives me 9 units. So that would be the solution for this problem. Students, we are expected to find the value of integral negative pi over 2 to positive pi over 2 x squared times cos x dx over 1 positive e raised to the power of x. Now 1 positive e raised to the power of x can be removed, and getting rid of that would result in the integral being multiplied with 1 over 2. So this can be rewritten as 1 over 2 times negative pi over 2 to positive pi over 2 times, I should say, x squared times cos x times dx. Now this is an even function, so I can rewrite this as 1 over 2 times 2 times integral 0 to pi over 2 with the integrand being x squared times cos x dx, because x squared is an even function, cos x is an even function, and together would result in an even function. So we can get rid of this 2 here and rewrite the integral as integral 0 to pi over 2 x squared times cos x dx. You can solve this by any method, either by the techniques which I have shown you or by this DI method. So I'm going to write the DI method over here, d and I. I take x squared under d and cos x under I. I differentiate this, I integrate this. So let me start off with the differentiation of x squared, which is 2x. Differentiation of x, 2x would be 2. Differentiation of 2 would be 0. Integration of cos x would give me sin x. Integration of sin x would give me cos x. Integration of negative cos x would give me negative sin x. So we start with a positive sign and then a negative sign, positive sign and then a negative sign. So we would write it like this, x squared with sin x, and the mapping has to be followed. So this is equal to, I start with a positive sign, x squared times sin x, then negative into negative, that's going to be positive, so 2x into cos x, and then positive into negative, so negative 2 times sin x. So this is the outcome. The limits are 0 to pi over 2. Now you can clearly see this is pi over 2 and 0, and this term will vanish. So thereby we would be left with just substituting the limits for x squared sin x and negative 2 times sin x. So I substitute the upper limit. This is going to be pi over 2 raised to the power of 2 times sin pi over 2 negative 2 times sine pi over 2. This is for the upper limit. I substitute the lower limit. This will vanish. This will vanish. So this is going to be pi squared over 4. Sine 90 is 1, followed by negative 2 times sine 90 is 1. So this is our solution for this question. Students, we are going to see another important property which is stated as follows. Integral 0 to 2a f of x dx is equal to integral 0 to a f of x dx positive integral 0 to a f of 2a negative x times dx. Now I'm going to show you the proof here. So foremost, let us consider the left hand side. So what do we have on the left hand side? Integral 0 to 2a f of x dx. I can rewrite this as integral 0 to a f of x dx positive a to 2a f of x dx. I would just like to consider this part, so let me just consider now. Consider integral a to 2a f of x dx. So now let us just make a following substitution. Let x be equal to 2a negative t. So from here dx is going to be negative dt. Now when x is equal to a, the limits for t would be a negative 2a is equal to negative t, therefore t is equal to a. And when x is equal to 2a, we got 2a is equal to 2a negative t, therefore t is equal to 0. So this can be rewritten as, in place of a, when x is equal to a, I get a. When x is equal to 2a, I get 0. In place of x, I substitute 2a negative t. In place of dx, I substitute negative dt. Now from the property in integral, I can actually change the limit. So this is going to be 0 to a, and thereby this negative sign would be dropped, giving us f of 2a negative t times dt. Also from the property of integral, I can rewrite this in terms of x. So this is equal to 0 to a f of 2a negative x times dx. So this is for the considered part. So if I were to take this as 2, therefore I can rewrite 2 as integral 0 to 2a is equal to integral 0 to a f of x dx positive integral 0 to a f of 2a negative x dx. And this is the right place to stop. However, I should subplace f of x times dx here. Right? So that is what we started with. So this is a good place for us to stop, and I will just say hence the result is proved. So we will move on to apply this property and do questions.